Okay, so today we're going to be talking about problems that involve position, speed, and acceleration. Okay, so first thing you should need to remember is that position, velocity, acceleration are linked by their derivatives. Velocity is the derivative of position, and acceleration is the derivative of velocity. Okay, because position is where you're basically your distance or your displacement, and then velocity is your displacement over time, which is basically slope. It is the slope of your displacement over time. Okay, so this problem gives us our position equation. S equals 5t squared minus 22t, and that's for all times greater than or equal to 0. Find the maximum speed of the particle and the direction of motion of the particle when it has this speed. Hint, maximum minimum velocity is achieved when the acceleration of the particle is 0. Okay, so the first thing you need to do is you need to find the equation for acceleration. Okay, so to find the acceleration equation, you first find the derivative, so v of t. And the derivative of 5t squared minus 22t is 10t minus 22. So that's my velocity. That means my acceleration, which is the derivative of velocity, is 10. Okay, so remember, to find maximums or minimums of a function, you take the derivative and you set it equal to 0. So if I'm trying to find the maximums of my velocity, I need to take the derivative, which is acceleration, and set it equal to 0. So when we do that, we take 10, set it equal to 0. Well, what are the solutions? Well, there are none. 10 does not ever equal 0, which means there are no zeros of the acceleration, which means we do not have a maximum speed. Okay, there is no. There is no maximum or minimum speed. Okay, which also makes sense considering my equation itself. Okay, now if they had given us a closed interval, then we would have had one. So if they said if it was only from t equals 0 to 15, okay, then we would say, well, since there are no critical points, there are no zeros of my acceleration, then we'd check the endpoints. But they didn't give any points. Okay, so this particle basically keeps going and going and going, and its acceleration is positive. Okay, and its velocity is going to be positive, which means it's going to be speeding up indefinitely. Okay, so there is no maximum speed this particle is going to achieve. Okay, so we're just using this basic idea, just like what we did with finding critical points and finding maximums and minimums, absolute versus relative. Okay, that's basically what we're doing here, but we're doing it with, instead of just f of x, we're doing it with position, velocity, and acceleration. Okay, so the next question. The position of an object at time t is given by the equation s. Find the velocity and acceleration functions. And what is the velocity for all integral times t when the acceleration is 0? Okay, very similar to the last problem. Okay, but this time, okay, we're going to find part A, which is to find the derivative, which is velocity. So v of t, which is the derivative of our position equation, okay, which is s prime of t. So basically, this is s prime of t, which is going to be, got to do product rule here. So the derivative of the first is 2t times the second, which is t squared minus 3t plus 4, plus t squared minus 1 times the derivative of the second, which is 2t minus 3. Okay, so that's my derivative. That's my velocity equation. Okay, then we FOIL it out and we add up our like terms, and we get our v of t, which is equal to 4t cubed minus 9t squared plus 6t plus 3. Okay, so once you FOIL this out and add up your like terms, this is my velocity equation, which you could have, if you wanted to, have taken the derivative of the way it was at the current moment, but you'd have to do product rule for the first part and do product rule of the second part. So it's much easier just to distribute the 2tn and distribute this out and add up your like terms to get the velocity. So that's my velocity equation. Now I need to find my acceleration, which is the derivative of my velocity. So when I take the derivative here, I get 12t squared minus 18t plus 6. Okay? So that's part B. Sorry, part A is done. Now, what is the velocity for all the integral times when the acceleration is 0? So basically, we need to find out, well, when is the acceleration 0? So we set this equal to 0. And then we factor to find our zeros. So we take out a 6, and we get 2t squared minus 3t plus 1 equals 0. Okay? And then, again, this is factorable. So we get 2t minus 1 times t minus 1, which means our solutions, our time values are t equals 1/2 and t equals 1. So both of our values are positive, so we're going to be able to use them. We would never use a time value that was negative because that would be basically before time 0. Most of these questions will say that, hey, it needs to be greater than time 0. Okay, so now the next part, since those are when my acceleration is 0, those are the times when that happens, we want to know what is the velocity when that happens. So we use our velocity equation and find v of 1/2. So we plug it in and we get 17 over 4, or approximately 4.25. And then we plug in 1 and we get 4. So these are the times, these are my velocities when my acceleration is 0. Okay? That's it. All right. Now, if it didn't ask us to explain it, we won't have to explain it. Okay? So, third problem. Okay, so it gives us a position equation again. It says make a table showing the position, velocity, speed, and acceleration of the particle at times equals t equals 1, t equals 2, t equals 3, t equals 4, t equals 5. Okay, so let's start there. Before we can even make our chart, we need to know our equations. We already have position, so we need velocity, again, which is the derivative of position, which is 3t squared minus 12t, and our acceleration equation, which is 6t minus 12. Okay, now all we have to do is actually plug in our values into these. Okay, so we're going to plug 1, 2, 3, 4, 5 into my position equation, into my velocity equation, and into my acceleration equation. So the position at 1 is -5. The position at 2 is -16. Position at 3 is -27, -32, -25. Okay? My velocity, plugging 1, 2, 3, 4, and 5, I get -9, -12, -9, 0, 15. And my acceleration, I get -6, 0, 6, 12, 18. Okay? Now, I'm not going to create a chart that shows speed, okay, because speed is the absolute value of velocity. So basically my velocity line, okay, is the exact same thing as speed. You just take the absolute value. Okay, so we're not going to worry about that. Now, part B, at each of these times specify the direction of motion, forwards, backwards, or up and down, if any, and whether the particle is speeding up, slowing down, or neither. Okay, so we have this chart now. Let's look at time equals 1. Which direction is my particle going? So based on my position, okay, I'm at -5. So that's either backwards or down, whichever one you want to pick. Okay, so you could think of it as a car going forwards or backwards and speeding up, slowing down, accelerating, positive, negative, all that stuff. Or you could think of it as something that's going up or down. Okay, I'm going to think of it more of as like a car going forward and backward because it's easier to think of something concrete. So if our position at time equals 1 is at -5, and again, if we think about it, at time equals 0, my position's at 0, okay? Because if you plug in 0 for position, you get 0. So I'm at -5, which means I'm going backwards, okay? Because I'm going in the negative direction, okay? Now, my velocity, am I speeding up, slowing down, or neither? Well, my velocity is negative, okay? My velocity is negative, which means I'm going backwards at 9 miles per hour. My acceleration is -6, which means I'm accelerating in the negative direction. Since my signs are the same, my velocity and my acceleration are the same, that means that I am speeding up because the signs are the same. Because my velocity is already going backwards and I'm going backwards faster. So I'm speeding up faster, going backwards faster. Okay? Now, at time equals 2, what's my direction? Which way am I going? Well, I went from -5 to -16, which means I'm still going backwards. Okay? Still going backwards. Now my velocity is negative. Okay? I'm actually going a little bit faster backwards. So I'm going -12 miles an hour backwards. Okay? But my acceleration is 0. So my velocity is not speeding up or slowing down. I'm actually going to be going the same velocity because my acceleration at this moment is 0. So I'm not, at this moment, neither speeding up or slowing down. My velocity will be constant because my acceleration is 0. Okay? Now, time equals 3. We look at position. Okay? Position right here, -27. So I'm still going backwards. I went from -16 to -27, which means I'm still going backwards. Okay? My velocity right here is -9. So my speed is 9 in the negative direction. So I'm going backwards at 9 miles an hour. But my acceleration right here is positive, which means I'm accelerating in the positive direction. And notice that my acceleration goes from negative to 0 to positive, which means my acceleration means going from going faster in the negative direction to not going any faster to now going faster in the positive direction. Since my velocity is negative and my acceleration is positive, they are the opposite signs. That means I am slowing down because my velocity is going backwards, but I'm actually accelerating in the opposite direction. Okay? It'd be like if you had a ceiling fan that was going around and you flip that little switch and the motor turns and it starts trying to accelerate it in the opposite direction it's going, it slows down. Okay? Now let's look at time equals 4. So time equals 4. My position is at -32. So I went from -27 to -32. So I was still going backwards that way. Okay? Still keeping going backwards. But now my velocity is 0, which means at this moment I am not moving. So technically, we are not going backwards or forwards. This should be neither, because I'm not going forwards or backwards. I'm stopped right now. My velocity is 0. I'm not going anywhere at this moment. Okay? I'm -32 from where I started, but at this moment I have not moved an inch because right at time equals 4, my velocity is 0. I'm not going forwards or backwards. Okay? Now, that also means that my acceleration is positive, which means at this moment, since my velocity is 0, I'm not moving. So I'm not speeding up or slowing down. I'm actually neither. I'm not speeding up or slowing down right here. I'm not moving at all. I'm actually about to change. It'd be like if you moving from reverse to drive. At that moment, you got to come to a complete stop for a split second to put it into drive so that you can start going forward. Okay? Now, this is where it gets interesting because now look at time 5. I'm at negative 25, which means from time 4 to time 5, I've had to start going forward because now I am not as far away from where I started. So this time 5, I'm going forward. Okay? And my velocity is positive, which means I'm now moving forward. Okay? So my velocity is positive, so I'm going forward now. It'd be like putting it into drive. My acceleration is also positive, so I'm accelerating in the positive direction while I'm going forward. Since they're the same sign, that means that I am speeding up. Okay? So these are the types of things you have to think about. So basically, when we look at our velocity and our acceleration, if they're the same sign, for instance, right here, they're the same sign. That's why here we're speeding up at time equals 1. Here they are the same sign. That's why we're speeding up at time equals 5. At 3 and 4, right here and right here, we're at neither because at times 2, our acceleration is 0, so we're not speeding up or slowing down. And here at time equals 4, since my velocity is 0, I'm neither speeding up or slowing down. Okay? And then at time 3, which is right here, I am slowing down because my signs are the opposite. Since my velocity is negative and my acceleration is positive, you're actually slowing down. It's the same thing if your velocity was positive and the acceleration was negative, you'd also be slowing down. So this is basically how you look at what's happening in a particle based on its position, velocity, and its acceleration.